Hello, and welcome to the 8th Kyushu University Science Salon. My name is Raymond Tanakadate Medal. I am a science communicator here at Kyushu University. We are back today here at our exhibition and observation room of the Ishigahara Terminus in East Zone 1 of Ito campus. Another beautiful day here today. 皆さんこんにちは、第8回九州大学サイエンスサロンへようこそ。私は九州大学のサイエンスコミュニケーターの国金ターヒューレイモンドと申します。どうぞよろしくお願いします。今日もまたこちら伊東キャンパスのイーストゾーン1の、石ヶ原古墳跡の、展望台展示室にいます。今日の、サイエンスサロン今回で8回目となりますが、またライブストリーミングに代わって、今回はちょっと録音とさせていただきます。サイエンスサロンというのは今回そもそも何というものは、旧大のビジョン2030すなわち、総合地で社会変革を牽引する大学を代表する研究を行っており、自分の研究分野だけでなくそれの隔たりを越え、新たな知見を切り開いている先生たちを紹介するシリーズです。So what is Science Salon exactly? This is a series where we'll talk to researchers across Kyushu University who are breaking new ground both within their respective fields and across disciplines. Each researcher's work reflects Kyushu University's Vision 2030, the path to transform Kyushu University into a place that drives social change with integrative knowledge. So today's guest we have today it certainly exemplifies this sogochi, this integrative knowledge. I would like to introduce Professor Huixin Liu from the Department of Earth and Planetary Sciences in the Faculty of Science. Her research field includes space physics and space weather. Professor Liu originally studied electrical engineering at Wuhan University in China, and then followed by a PhD in space physics in the Max Planck Institute for Solar Physics in Germany. She has been awarded the Shiseido Award for Outstanding Female Scientist, the Nishida Award from the Japan Geophysical Union, and the Tanakadate Medal, among many others. I bet there's some updates we can make to that as well. 今回ゲストに来ていただいているのは、九州大学理学研究院の地球惑星科学部の劉福信教授です。先生の研究分野は、宇宙物理と宇宙天気です。先生は、中国の、武漢大学で電気工学を学び、その後ドイツのマックス・プランク天体物理学研究所で、宇宙物理学博士号を取得しました。先生は数々の賞を受賞しており、その中では、資生堂女性研究者サイエンスグラント、地球惑星科学振興西田賞の田中伊達賞などを受賞しております。趣味としては太極拳とランニングが趣味としてありますので、それもまた後でお話しします。We'll talk about your hobbies of running as well as Taichi. So let us begin. Thank you very much for joining us today, Huixin.
Thank you for having me, Raymond. It's always a pleasure to talk to you.
It certainly is. It's always a pleasure to learn about your work. And I think absolutely having you today as a guest on a nice, beautiful day like today is very much appropriate. So the topic today we're talking about is basically your research, and the question being, what is space weather, and why do we care about it, or why should we care about it? So I guess the first question being is, well, what exactly is space weather? What is uchu tenki? And what is your research exactly about?
Yeah, and my research field is actually space physics. And by space here, we basically refer to the space between the sun and Earth instead of the universe far away, you know. And so normally we care about what is in this space between sun and Earth and how it changes. And nowadays, and this field is often referred to as space weather. Maybe some of you have already heard. And because it's getting more and more relevant to our expanding activities in the space, and including space travel recently. And so, of course, you ask them what is exactly space weather, and simply it's weather in space, we can say. And just like here on Earth, and we have sunny days and we have rainy days. And in the space, actually, the space environment is also changing from day to day. So, and this change from day to day is called space weather. And so some people might ask, well, isn't the space empty?
Yeah, exactly, yes.
Right, and well, I mean, compared to like our living rooms, the air is certainly very thin in the space, but it's not empty. And so, for instance, in a space like 1 cubic centimeter, like something like this, how many particles are still there? Can you give a guess?
In space?
In space.
10.
So that's why you think it's empty.
Yes.
In reality, it's 3 million particles in this small space, 1 cubic centimeter. So you can see it's not empty. And then when the satellites and flying objects, they fly through this air, although it's very thin, but because their speed is very high, so they still experience very high drag, which can affect their orbit. Just like when you drive car, if you drive faster, you actually feel stronger drag, right? So even the air is the same. So it's the same because the satellites, they are flying so fast, like 8 kilometers per second. So you can compare with your car speed. And therefore, it's this air, although it's very thin, it's very important for satellite orbit control, let's say. And plus, within this, like 3 million particles, and there are some particles are actually charged. So charged particles, we call it plasma, right? Yeah. So we know that the plasma, because they are charged, so they interact with the radio waves. And therefore, it affects the radio waves or whatever technology use radio waves. And this can be broadcasting and satellite communication and also like GPS navigation and positioning systems. And so by now, I think hearing this, you can already understand that just like the weather is very important for our daily life, and the space weather is very important for the daily life of our satellites and rockets and space stations, everything flying in the space. And that's why recently, there are a lot of governments, they start caring space weather in this field.
Oh, wow. So, just even that short explanation and understand how important your research is. So where does where does like space weather come from? What causes space weather? I guess here on the ground level, there's rain, there's heat, there's water evaporation that causes different weather patterns. Is that the same up in space or up in space, or where you look at where space weather happens?
Yeah, that's a very good question, actually. So what causes space weather? What causes the change in the space? So because we are talking about the space between the sun and the Earth, so we get a lot of energy from the sun. So basically, the major cause is actually from the sun. And normally you might see, okay, the sun is so calm, but actually, if you look at the sun with like a telescope, you will see there are a lot of activities going on the sun. And some days it's calm, and some days maybe it's blowing off a lot of high energy particles. And those, they blow towards Earth and can cause quite some disturbances in the Earth environment, and therefore cause the change where the satellites care.
So nothing here on Earth specifically will affect what's happening. Does anything? Well, which is the question is, does
Right.
anything happening here on Earth affect space weather? Is it only really just the sun?
That's a very professional question, actually. And normally, right now, I said it's mainly the influence, mainly coming from the sun. But recent frontier research in space weather is actually, the cause is coming from below, actually from our environment, particularly like weather phenomena like a typhoon and a volcano and earthquake, and they can also sort of, general turbulence in the space, which we have not thought before. And therefore, so to summarize a little bit, what caused the weather in the space? So main cause is from the sun, and the second cause is actually from the Earth weather. So you link the weather with space weather.
なるほど。So it's like to rephrase a little bit in Japanese. So
Right.
宇宙天気っていうのはその地球から太陽の間に起こっている天気であって、その主な現象は太陽がオリジンですね。太陽からのエネルギーがその宇宙天気を動かしている is causing space.
が原因である。
でしかもその宇宙天気でいうその宇宙で起こっているこの天気現象は今はその衛星であったりコミュニケーションインフラであったりも今の現代の生活 modern lives に大きく影響しているのでそこでそのこの研究は重要であるということでよろしいということは本当に分かりますね。
That's the message I wanted to convey.
そう今欠かせない研究ということですね。When did this field of space weather or your research exactly begin? Because our modern space age or like the output of satellites is only relatively recent in our modern age. But like this idea of space weather or the sun affecting what's not down here but up there. When did this whole research kind of start up, or how did it begin?
This research field is actually relatively new compared to all the other fields. It's now maybe you can say sort of a little bit over 100 years, and the discovery was maybe in the some 1800s, end of 1800s. So some people like Gauss, they do some measurements on the Earth and using magnetometer. And they found that the magnetometer is changing day by day, and then they imagined something must be changing in the sky, and there must be some currents flowing in the sky instead of just on the ground. So that's how they sort of discovered the so-called, ionosphere and things. And then, after that, they start to examine what caused this thing, and So that's the whole, it's sort of like the discovery of teleconnection between the sun and the Earth's upper layer, which we previously thought that is really empty, but actually not empty. There are a lot of electric fields, there are a lot of electric currents flowing there, and I think that's how it started. And then it really gets accelerated since the 1950s, where we had satellites and rockets, and then you could really go there, right? You could, instead of just measuring so far away, like a remote sensing, you can go into the space and mirror it, and therefore, and there was a great expansion of that.
Oh, cool. So so a relatively new, especially in the field of physics. Physics is probably one of the older field of science, but now it's expanding like this. So I think last year there was some news on just a lot of like auroras happening in like much further southern than people expected, or some GPS signals going out of whack. So all of this is related to your work, essentially.
Right. It's a major part of the space weather research, actually.
And so we mentioned that we feature researchers who are very representative of integrative knowledge, and your work sounds like, well, based on being relatively new, require a lot of different kinds of knowledge and interdisciplinary work. Could you, your background is in electrical engineering, and then you have a PhD in space physics. So how, can we connect like a little bit of your background and how your field is, interdisciplinary work is necessary, or how cross-disciplinary work is important to your work and your background?
Right. I think in terms for integrative knowledge, right, and space weather is actually a very good example. And we can basically function from 3 aspects. The first one is in terms of research or science. And the research itself, like space physics, right, basically involves quite a few disciplines, from like solar physics and plasma physics and also meteorology, and therefore you really need different people from different fields to really understand the whole chain of the cause effect for space weather. And that's from research aspects. And from the second aspects is from the space science exploration. It's very closely tied to space technology. Right now, we said because we want to measure in situ, we want to go there and measure. And so for this, we definitely need all these rockets and satellites and all the instruments, all the payloads on these rockets and satellites. So you can't do anything without space technology or this engineering part. And the third part is the application. From application side, space weather application is actually directly related to the let's say technological infrastructure of our modern life, and basically including what we just mentioned, the broadcasting and satellite communication and navigation systems, and now also with space travel on the horizon. So I think space science is really becoming a very, very prominent field of integrative knowledge that includes all these components like space science, space technology, and space travel, and maybe the economy that it brings. So yeah, I think it's very, very relevant to the integrative knowledge.
That's absolutely what we wanted to hear. And going into that, then we can talk about some of the people you work with in the lab you hold. And your lab is known to be very diverse, with a lot of different fields of people in your lab. Could you do a little bit of, you can do a little bit of jiman of your lab if you want to as well. But what kind of people and students do you have working for you or work with?
And we are very proud of being very, very diverse in the lab. So we currently have people from 6 countries, from all the continents except for the poles.
Oh, wow.
Basically, yeah. So I think it's really a big diversity in terms of nationality and gender, and also career stages. And most students, there are a lot of students from, of course, Japan, and in addition to that, there are a lot of students also from US and Germany, where my major collaboration comes in. And so, yeah, and for this kind of diverse lab, let's say, and we also, in addition to these different students, we also have constantly some visiting scientists. So they are, relatively more advanced in their career. And then, of course, we have postdocs. So in terms of this career stage, I think it's also diverse. And plus, currently we have 15 members, and half of the members are girls.
Ooh, wow,
So
excellent.
that's in terms of gender. I think it's also a good balance. Yeah.
That's amazing to hear, and absolutely fantastic. Especially perhaps especially in like the fields of physics, perhaps you don't hear a lot of younger female researchers being active. Maybe like biology tends to have more higher ratios of females than males, but that's are these the people? Yeah. So could you explain like some of the work that they do, kind of related to? You also explained that there's so many interdisciplinary aspects to space weather and space physics. So what kind of work do each of your postdocs or students do in your lab?
Right, and the students, they are also doing quite different works actually. And right now we said that space weather is particularly related to the space technology, and there are particularly two different direction. One is, the orbit of the satellite, and the other is the communication. And so some students are basically working on this, how the space weather affects the satellite of the particularly the satellite orbit, and they do some simulation. So when there is a flare or when there is aurora happens, normally, the Earth's atmosphere will expand, and therefore some satellites, their orbit will change. Just like 3 years ago in 2022, SpaceX had quite some satellites dropped down, and that was basically one of the reasons. So one student, or actually two students, are now doing this type of work, and to see how the air expands and how it affects the satellite orbits. And so this is one type, and another type is how the things affect the communication, like HF communication, right? Normally, particularly the ships, and they communicate with this HF high frequency. And when there is kind of like irregularity in the space, and we call it sporadic E, and their signal can jump to completely different direction. So although like I want to, communicate with someone there, but there is something there because the signal normally go this way. So it needs a reflection from this space and then go down again. So when this thing changes, and then your signal will fly to quite different places. And so some students are doing this type of thing.
All related to space weather.
Right, related to space weather. And we recently actually, one of the recent results is that with the Tonga eruption, was it also 2002? There's Tonga eruption. And we found that the Tonga eruption actually disturbed the ionosphere and this kind of irregularities we're not saying, and they generate a lot of irregularities because normally in winter there is not so much irregularity, but after the Tonga eruption, the volcano erupted, and then there is suddenly a lot of irregularity in the space there, and then there was sort of disturbance in the communication in HF.
So I guess in that two questions is you mentioned in wintertime there's not a lot of irregularity. Why
they
is
have,
that exactly?
This is a bit more towards the research side. And so in the space there is also season, right? And so, so some phenomenon, they just like on Earth, they occur in certain season, but not in others. And so that's also a sign of, so basically it's space weather and space climate. So there is day-to-day variation, and there is also climate, season-to-season variation.
Okay, well there's a new term there. It's space climate.
It has been there, but but maybe people are more sort of sensitive to space weather.
Oh wow! So wait, okay. So
Yeah.
now that you mentioned these things, then so with the Tonga eruption, what was the cause of the disruption to space weather? Was it just dust that gets thrown up, or is there something specific to volcanic eruptions that disrupt the ionosphere?
Yeah. So normally this cause from below. We normally say that from the weather system, right? And are mainly related to atmosphere waves. So of course, the eruption also spit out some chemical stuff, right? But that's not the main thing because they can't really go very high. But they do generate some waves. They say the most simple one is sound wave, you know. And sometimes, yeah, when there's earthquake or there is a volcano, and you actually do hear some sound, right? So they generate some sound wave, and there is also many other type of waves, which you normally do not hear. Some is Lamb wave and gravity waves, and so these waves and they can actually go up very high to the ionosphere, and to cause some disturbances in the ionosphere, which falls into this category of space weather. So atmosphere waves are very important for us.
So that's how a lot of stuff down here can affect space weather.
Right.
A lot.
Right.
You mentioned a little bit about space climate. Does I take it the understanding of what climate from people on Earth might be a little different, but it seems just from my understanding was okay, the ionosphere is kind of surrounds the Earth, and what changes climate here on Earth is the tilt of the Earth's tilt, what's in the atmosphere. But what are the things that affect the climate, or and how does what do you mean by climate cycles in space weather or in space climate?
Yeah, that's still not very 100% clarified, and so of course, I mean, the Earth is rotating around the sun, right? So the position is different. So that's why how you get 4 seasons on the Earth's surface, and also actually in space, because even in space, and still the radiation you get is different, right? In different seasons. And so for us, when we say different seasons, actually when you look at the orbit, Earth orbit around the sun, it's actually a different location. And from the sun, there are a lot of things coming out. One is radiation, maybe more uniform, but there's another thing, it's called solar wind. So it's not only the radiation part, there is also, from the sun, there is also a lot of wind, let's say, blowing out, carries a lot of high energy particles. And this wind is actually not uniform. So in certain direction, it's thicker, it's stronger, and so there are different sectors, right? And so you can imagine there are different sectors with stronger wind, with weaker wind, and then your Earth is just traveling through these sectors. So of course, when you're in the stronger wind sector, you get stronger wind. But when you're in the weaker one, you get weaker. And there is also so-called magnetic field in the solar wind embedded, and that's also changing depending on which direction, which degree, which angle you are. And those, they cause sort of longer term changes of the space environment, let's say, around the Earth. So sort of climatology things. Yeah.
And so I can this would be very important for any kind of satellite or doing space travel. You don't want to be in a kind of a precarious situation with strong solar winds could cause or what have you. You did mention in the beginning that space weather, or what we understand, or the research in the field of space weather, is from Earth to between Earth and the Sun.
Yes.
How about other planets or even exoplanets? Right now there's talks trying to get to Mars or something. But is there space weather also on Mars, and is that a field of study? And how about other planets that can outside of our old solar system that we see? Is there a field of research in there, and what's the what kind of ideas are being formed
Yeah.
there.
First, I don't work on X planet. So although I do work on Mars. So,
okay.
Yeah. So basically, it's the solar system, right? Mars is still in the solar system, and so I recently, actually, from 2 years ago, we started doing some work or space weather on Mars, and basically the phenomena are quite, or let's say the physics is quite similar. I mean, it's Mars, it's also affected by the sun, and then there is also sort of Mars also has ionosphere and atmosphere, so it does have this kind of coupling process going on. Although the exact phenomenon can be different, and for instance, here on Earth, we say, okay, volcano eruptions can cause some space weather on the Earth's environment, right? But for instance, on the Mars, it's not the volcano, but it's the dust storms. Dust storms, I think it's very famous. Many people know, right?
Yeah.
Mars, why Mars look red is because there is dust storms very often. And so when there is dust storms, they also can cause some disturbance in the Earth, in the Mars environment. So yes, so there is, space weather on other planets as well, at least in the solar system.
Oh wow!
Yeah.
But obviously Mars and Earth are being significantly different.
Right.
I'll be interested to hear more about your
we can
Mars
chat more on
research
that.
a little
Right,
later.
right.
That'd be fun to write about.
Right.
That's really.
Yeah, and just one point is the big difference between Earth and Mars is Earth has a very strong magnetic field, and on the other hand, the Mars doesn't have a strong magnetic field, and has only some remnant field on the surface maybe, and that make a whole lot of difference within the space weather. Because for instance, aurora on Mars can look quite different.
Oh wow!
And they don't have the sort of like a oval shape aurora on Earth. If you look the Earth from the satellite, you see an oval shape of the aurora in the pole. But on Mars, there is nothing like this because there is no magnetic field, and so it looks very very diffused. Let's say just on the whole surface on the day side, and you see some diffuse aurora.
So it's the sky changing a little bit.
Right. So it's not as beautiful as aurora on the Earth.
Oh wow!
Not as intense and not as nice shaped ring. Yeah.
So if so ideally the auroras and also a lot of the phenomena we see come from the magnetic field of the Earth.
Right. Magnetic field is very important in producing aurora. Actually, producing strong aurora.
I see.
Yeah.
The little bit more on the magnetic field side. Those are critical in also like space weather and how the Earth handles solar winds. But so is that another dimension in this field of research, just looking at like the Earth's magnetic field, or is the entire scope of space weather kind of looking at the Earth's magnetic field in a more indirect way?
The Earth magnetic field itself, and for us, it's almost like constant. Because the Earth magnetic field changes only several hundred million years, and it doesn't change that much. Yeah. So for us, it's like something like a background, and so what we care is the perturbation on this background magnetic field. So how it interacts with the magnetic field from the sun, and so that's the part that we are interested in. Instead of the evolution of the Earth's magnetic field itself, that's outside of I think space weather field in a way.
Oh, that's very cool.
Yes, very cool. I think so.
A lot of different dimensions.
Right.
Yeah. So I guess we can move on a little bit to kind of your work as your other work outside of the lab, but here at Kyushu University. One of the things that this isn't the first time we've talked. This is the first time we've featured you in some of our media. But one of the ones that we've talked to you a lot before is with like Sentankyu, as well as your work as your work at the lab at Kyushu University. And this is the program that's that's called the Diversity and Super Global Training Program for Female and Young Faculty Program. And you were the Sankisei, third generation, for that. And this is certainly a program that Kyushu University is very proud of. And we've had some phenomenal researchers. I think like most of the research we've talked to in the past have some relation with Sentankyu as well. But could you explain a little bit of this program? How did you get into it, and like what, perhaps like how has it helped you in your career here at Kyudai?
Yeah, like you said, Sentankyu is designed to basically increase the number of like female and younger researchers in the senior faculty positions. And so the program actually offers a lot of opportunity for, particularly training opportunities for the interactive education style, interactive teaching, and also how to carry out the international collaboration. And in addition, it also has some seminars on, let's see, university governance. And so, and then for me, the first two parts, interactive teaching, I have been doing that in my classroom for quite some years. And also international collaboration is not a big problem for me either. So what I found interesting for me is the governance part. And university governance, right? Previously, as a normal researcher, we never hear or learn about these things. And so through these seminars, I think I do learn, how the university operates, and also like it helps me to develop a kind of mindset, let's say, to think at the university level instead of as an individual at the individual level as a single researcher. So I think these are very important for me, and I think I do grow by attending these kind of seminars. And in a way, it also, this kind of mindset actually helped prepare me for the job I'm currently holding, which is the Vice President of the University for International Collaboration and Education.
Phenomenal. Yes, I think especially when it comes to Japanese universities, professors or like people in senior positions end up taking on a lot more administrative roles, and not just outside of their actual research roles. So learning about university administration and about the ins and outs of how these things work, it's very valuable.
I think it's very valuable, and particularly I think this, in a way, actually, not only this Sentankyu people learn this, and they actually maybe should sort of expand it a little bit so that all the faculty members will be able to, learn how the university operates, and to think at a higher level, at a bigger level, let's say, right? Instead of only thinking my own lab. And I now think, how we can improve the research environment in the whole university, and not only for me, but for all the faculty members, right? And how do we do that? Like, for instance, through some efficient sharing of the university resource and things, So I think that they should sort of expand at least this kind of, seminars to the whole university.
Taking your experience and this, like, what are some of the possible, expanding on that, so like what kind of other solutions or ideas do you have that can perhaps that will help university researchers and help universities, Kyushu University, operate better or produce it already produces great scientists, but even more better scientists. Kind of like, with your experience, like what kind of ideas do you have?
That's a big question. There are a lot of Liji Dachi figuring out those things. Yeah, so I think it's a very very complex system, right? Particularly for big universities like this, you have so many layers, and you have so many different departments and faculties, and so it's really important maybe to how to balance things out, and also how to really inform. I mean, a lot of ideas are very great, and but a lot of people are not informed, maybe. And so this, I think, like right now we said, if they give more seminar, like this kind of how to inform or to introduce how the university is working and what is the current problem, to do a little bit more. That can be very helpful. And then all the faculty themselves will automatically think differently. Currently, maybe many cannot really see the big problem, or it's hard to immediately change. It's very challenging. I think that's very challenging question and very challenging problem. Not only for Kyushu University, maybe for all the universities. Yeah,
the big ship, it's hard to turn, but knowing how the system works is good.
It's very important. Yeah. So first, I think you have to know at least how things work here, right? And then you see the problem, and then you see how to change. But even if you don't know how the current system you're in, how it's working, then it's impossible to improve it. Yeah.
So, speaking of improving systems, you're also part of kind of more of the international researcher community here, and working for more internationalizations with CIAG. Yes. I don't have it written down here how that is, but it's a group of international academics and researchers here at Kyushu University who try to put out policy proposals to improve internationalization here. How has it been as an international academic here at Kyushu University? And what kind of work is CIAG up to, trying to better the environment here for international faculty?
I think Professor Lawrence has been doing a great job in leading this group, and always very active and exciting like discussions and things. And they collect basically a lot of feedback from foreign faculties in different faculties, like engineering, science, and all other departments. And so I think it's very helpful for, if you're in such a group, you will understand things can be different from different departments. So it helps you to see an overview. Instead of, if I'm not in that group, I may only see my own faculty, like Faculty of Science. Things work like this, but once you hear all these kind of discussions in this committee, and then you find, okay, and actually, that's not only my own problem, and that's more general problem that maybe we have to improve it. So I think, in that sense, it's very helpful to discover some general problem and to solve it. And at the same time, it's also good to see which faculty is doing better than others, and then you can sort of, there's a good examples and good practice that you can borrow, and you can introduce into your own faculty. So I think it's this kind of exchange information and exchange of know-how is very helpful.
Even for me being here in the PR office, I'm continually. We also work on trying to better internationalize, and we work English primarily. But I'm still continually surprised at how many international faculty there are here at Kyushu University. It's like, this department had these people here working on that. So Yeah, I'm happy to
Right.
hear that there's this good amount of communication happening. It is obviously a very big campus with
Yes.
a lot of people
Yeah. Yeah.
here, and that's
Right, it's
trying
a
to
very
hear,
good
yeah.
organization.
Yes. Oh, wonderful. Okay, so a little bit to wrap up. Yeah, we said we would talk about a little bit of some of your hobby on one of the
Yeah.
things that especially the domestic PR side has been really happy to talk to you about is your running
Yes.
club and your running,
Right.
well, I don't want to say career, but your extensive running experience. You've done, we saw you run at the Fukuoka Marathon just the other day,
Right,
and your next one is like you're going to Kyushu.
No, I'm actually next weekend.
Next
I'm going
weekend.
to Nagoya.
You're in Nagoya next weekend, so
Yes.
that's
Yeah.
already
Yeah.
already two within the last
Right,
4 months. So
right, right.
and you have a lot of your your
Mhm.
lab is also
Running
possibly
together.
running club. So tell me about this your hobby. This hobby of yours on running. When did it start? Why?
Yeah.
What compels somebody to run like all this distance?
Yeah. We are very proud of being runners, and in the lab, sometimes we do run together, or we train together actually before a race, and so which is always quite enjoyable. And well, I liked running when I was small, and I was quite good at 10 kilometer actually. And so you're asking, how I got into this long distance running, right? And so that I started long distance running actually after I moved to Itoshima.
So
Not too long ago, yeah, about 4 years ago. And there I joined a volunteer group called Patrol Run Japan. I don't know whether some of you have heard. And so the basic purpose of this group is like a city security and cleanliness while you're running. You try to pick up some trash or try to walk around, to see whether there were some bad people doing some bad thing while running. And so it's a very nice volunteer group. And of course, I mean, a lot of people are runners, and a lot of people I found they are marathon runners, which I did not know before joining. And therefore, once you're in this group, I mean, you're influenced. Everyone is having, so many talks and so many experiences. So, and therefore, with them, I also, my running distance also grows longer and longer. And we do a lot of activities together. And for instance, this new year, we did like a 30-kilometer tour de shrine.
Whoa!
So we visited like 25 shrines in Itoshima.
Amazing.
30 kilometers.
Oh,
Yeah.
goodness.
So I think through all these activities, I discovered the joy of group running, and also I think also the truth of the old saying, which says that if you want to run faster, run alone, but if you want to run far, and run together, and that's really true. Yeah. So I think that's how I got into, and I certainly do enjoy it.
Do the people entering your lab know about the running club?
They do.
Okay,
Yes.
so
Yeah.
they understand what they're getting into when they start
Right.
working for you. It's like,
Right.
you're gonna have to learn how to do long distance running too.
Right,
Oh,
right.
wow.
Long distance running. Yeah, it's for me. I mean, it's really becoming a very strong hobby. And one thing right now is that there's a joy of group running, but there's another thing that is why do I run, right? I mean, different people run for different purposes. Maybe some people run for health, and some people they run to lose weight, let's say, and some others maybe run because their girlfriends are running and things. But for me, I think running is in a way is basic to relax and to meditate. So what I'm looking in the running is actually, maybe health, but certainly not to lose weight. Is rather to look for, in a way, sort of emptiness and space, because you want to relax, you want to meditate, right? And therefore, you were asking me what I think when I was running.
Yes.
So the answer is actually I try not to think while running, because I'm looking for this emptiness, right? And therefore I try hard not to think of anything, just concentrate on the running itself, like breathing, like the sound of your footsteps, and all these kind of things. And of course, sometimes, if there are too many things on my mind, like this morning I was thinking about it, so some thoughts, they do manage to creep in, and normally when it does happen, normally I start counting numbers, try to drive these thoughts out. Yeah. So overall, running is very relaxing, and it's strongly recommended.
Wonderful. Yeah. Oh, that's great. So that, I guess in the final just question, or just kind of like to wrap up everything in our talk, like what kind of like message or advice do you have to younger researchers, or if you could give advice to a younger version of yourself?
Younger version of myself.
People seem a lot of people look up to you and look to your career for inspiration. What kind of like advice, suggestions, or ideas do you have for them and for yourself and for the future?
And in China we have a word called Kyushu U. It means, so we normally compare a person's growth to the growth of a tree. And in a big tree, right, you need a strong trunk if you want to have many branches. And similarly, so I think as a person, if you want to be successful, and you have to have a strong major to be able to broaden out later. And therefore, I think I would strongly recommend younger people to focus to focus on one topic and become an expert on it first. And then this expertise will become your trunk, the trunk or backbone of your profession. And then once you have this one, and then you can, broaden out to more branches and to wider field. And therefore, I think that would be my advice, to focus on one topic and become an expert on that. Yeah. Because if you try to you try to broaden earlier, and then you risk to become bushes, grasses, yes, let's say, instead of a big tree. And therefore, to concentrate is very important, I think. So that's maybe, for some people, that maybe sounds like, okay, it's against the current trend of like being a generalist, like knowing everything. But my impression is that if you're too young to become a general, you broaden out too early, and then you do become a generalist, which is actually means you are not good at anything, right? And then you really become just bushes and grasses instead of big tree. So that's my advice.
So how about so what for you, as a tree, as a big strong tree?
Well, I'm not big, I'm very short.
But how about for you? What is your what's next, or what's moving forward for you? Where what ikigomi?
My ikigomi running.
Running, yes.
Marathon. So I need to improve my time. Every time, and of course for the profession, and I have a lot of things I want to do, and particularly for research, for space weather particularly, we really want to develop some space weather forecast program, and some skills also in the lab to make it as a characteristic of the lab. Currently we are basically doing the research. We're not really extending too much on the forecast part. And so I think that's my short-term goal for the next 5 years. Yeah.
So like a 宇宙天気予報士.
宇宙天気予報士. Right. Yes. Yeah.
That's, I guess a meteorologist isn't the right word for that. What, like
Space meteorologist.
space meteorologist?
Yeah.
That's going to be a new field of career that's going to have to be done for researchers.
Yeah, I'm sure it's coming in a way, and I would certainly like some of my students to be able to become the first generation of forecaster.
Oh, that's really cool. That's a great way. I think that's a great way to kind of wrap up everything. So, thank you very much, Huixin, for sitting with us today for this interview.
Thank you for having me.
どうもありがとうございました。
ありがとうございました。